So this is my third node I have. Okay, and this is my fourth node. So we'll see a doubly linked list. So it is having 4 elements in it. Okay, so as it is a doubly linked list, okay, so that is connected with what we'll say some nodes. Okay, so this is for what we'll say every node will have 2 links. Okay, so that is one is next link and one is previous link. Okay, and every node will be in 3 parts. Okay, so can you tell me if there is a question? Okay, what is the size of a node in a doubly linked list? So what is your answer? If anyone asks you what is the size of node in doubly linked list, so what is the answer? Size in bytes?
6.
6, okay. Any other answer? Why it's 6? You are saying 2 plus 2 plus 2?
Yes, sir.
Okay, so yes, so 6 will be there. Otherwise, if it is a 64-bit system, so it will be 4 plus 4 plus 4. Okay, so the size of a single node, 4 will be for previous pointer. 4 will be there for data. I won't say 4. Okay, so that is dependent. Okay, so I will make it star. Okay, so it may be anything. Okay, so suppose that is an element as a character, so that will be a size over here. Okay, whatever the size it may be. But if we consider a node with a structure, so that will be 4 and 4. Okay, so sorry, if we consider this as an integer, so that will be 4 plus 4 plus 4. So the total size will be 12 bytes. Okay, so if we have a question, okay, so how much is the size of the structure of a doubly linked list? Okay, so the proper answer will be 12, and maybe probably the structure will be given to you, so that will to estimate the size. Okay, so that we can put over here. Okay, so that we have over here. So now, okay, so now what we have to do? So yesterday we have seen, so already every pointer, every will have the forward and backward link. So this backward is previous, it's pointing over here, its next pointing over here. Okay, so again its previous is pointing over here. Okay, its next is pointing over here. Okay, again its previous is pointing over here. Okay, and its next is now at the last. Okay, so that will be null. Okay, so the last node's next is null, and head nodes or first node's previous is null. Okay, so we'll keep 2 pointers. Okay, so one pointer we can say as a head pointer. Okay, so one pointer we can say as a head pointer, and another pointer you can say as a tail pointer. Okay, so this is the terminology that we have seen. Okay, so this is the example that we have will see. Okay, so I'll just make this like particularly. Okay, so this part we have. So again, this partition we have like 3 components over there in a node. Okay, and suppose there are few numbers I have. Suppose we'll have some numbers. Okay, so the first will be having number 6. Second will be having number 8. Okay, next will be having number 5. Okay, and next will be having number 3. Okay, so these are the 4 nodes we have in our hand. Okay, so suppose now we'll perform a few basic operations. Okay, so to again get more clear idea about this. Okay, so one operation will go with search. Okay, the second operation will go with delete. Okay, the third operation will go with add element. Okay, add pose, I will say, any position we will see. Okay, so these are the few things that we'll perform in this lecture. Okay, so I hope you already have implemented in your program. Okay, so basic things that we have learned. Okay, so you may guide me. Okay, so my search key. Okay, so key to be search is suppose 5. Okay, so tell me how we can write the code for searching the element. I have to check in doubly linked list whether the element 5 is present or not. So tell me how we can do this. Yes, anyone?
So temp is equal to head, and then until temp is equal to null while loop लावायचा, and नंतर मग if temp data is equal to 5, then return.
Yes, so the same. Yes, good one. Okay, so we'll just see while. Okay, so it will be temp next not equal to null. So this always you must remember this loop while implementing this linked list part of point of view. Okay, so we'll have if. okay, temp data is equal to key. Okay, so in that case, we'll just say, okay, so we'll just see out. I'll just make found, and we'll take one element, okay, that is POS as one element. So that will be, you can increment POS, okay, so POS plus plus you can make, and here we can directly make back once it is found. So no, what will say anything we need to do for going forward. Okay, so I'll make POS plus plus, okay, and we'll initially make POS as 1, okay, and finally you can print the number found at this position. Getting? So this much is simple. Only temp data is equal to key, then we'll break and come out of. So any doubt in this searching part?
No, sir.
Hello? Yes, is it clear? The searching part is clear?
Yes, sir.
Yes, sir.
So I hope everyone is going through this. Okay, so searching is here. Okay, so now we'll go for delete. Okay, so the second operation we have to perform. So that is delete we have to perform. So I'll just make this. Okay, so now for delete, just tell me how we can operate on delete operation. How we can work on delete? Suppose I have to delete element 5. Okay, so I will just remove this now. Okay, so I have to delete this element 5. So what will be the code that we have to do? Yes. Yes, what should I have to do for this delete operation?
Temp next equal to null.
Yes, so again the same loop will just go. So while
सर ते if पर्यंत सेम असेल आणि नंतर मग if मध्ये थोडंफार
yes, temp next not equal to null. Okay, but is there the good way so that temp next not equal to null means temp will be reached at which position? Where temp will be reached at 5, na?
yes
I
sir
will do temp next not equal to null. Okay, no issue, but we have previous and next link also. Suppose we'll have temp next not equal to null, and we'll just see if. Okay, we'll just found temp data is equal to key. Okay, so tell me now what we can do. So now we'll have this particular point over here. Okay, so we'll just see temp is now at this position. Okay, so temp is at this position, and I have to delete the links over here. So tell me how we can delete. Okay, so the first thing, all the backlinks and front links will be reconfigured. Okay, so just tell me how we can do this.
सर टेम्प प्रीवियस को टेम्प नेक्स्ट से कनेक्ट कर देंगे सर, मतलब टेम्प प्रीवियस का नेक्स्ट टेम्प नेक्स्ट हो जाएगा तो और बीच
Will we
का
write like this? Temp previous next is equal to temp next.
यस सर
Temp
Yes, sir,
is
yes, yes,
temp,
yes,
its
sir.
previous, and its next will be temp next. Okay,
यस
and next thing what we have to do?
सर टेम्प नेक्स्ट का जो प्रीवियस है वो टेम्प का प्रीवियस हो जाएगा सर.
Okay, so okay, so what with this temp previous next? Okay, so temp previous is this 8 number. Its next we have made temp next. So now 8 is pointing to 3. So now 3 should point to 8. So what we have to write? Temp next.
The next previous is equal to temp previous.
Temp previous. Okay.
And फिर
we'll
delete
just-
temp कर देंगे. Delete temp.
Okay, so delete temp better way. Okay, so delete temp you can do. Otherwise, you can take one another X element. So that should be deleted. Okay, so now we'll just see how it is working now. Okay, so now how it is working. So it's we'll take like this. Okay. Okay, so what we did. So temp previous next. Okay, so temp previous is this. This is temp previous. 8 is temp previous. Okay. It's next. Okay, so this is the next pointer. Okay, so temp previous next, okay, is equal to temp next. So this is the temp next. Okay, so what is temp previous next? So this will be 3. Okay, so we'll connect over here. Okay, so temp previous next will be 3 over here. Okay, and next is what? Temp next previous. Okay, so temp next is 3 and its previous is this. Okay, temp next is this and its previous is this. Okay, so it is equal to temp previous. Temp previous is this. Okay, so temp next previous is equal to temp previous. Okay, so that is connected. Okay, so this is connected and we have deleted this. Okay, so once we have deleted, so this whole node will be deleted, so there is no reference to this node. Getting? So how deletion will be done over here?
Yes, sir.
सर सर
Yes.
बट यहाँ पे वो टेम्प नॉट इक्वल टू नल बेटर रहता सर, क्योंकि फिर हम लास्ट नोड तक पहुंच पाएंगे सर, वरना हम लास्ट नोड तक जा ही नहीं पाएंगे सर ना, अगर टेम्प नेक्स्ट नॉट इक्वल टू नल हो गया सर.
Yes, temp not equal to null is the correct one. Yes.
Yes,
So
sir.
you have to make temp not equal to null. So that's good one. Okay, so this we just modify. Okay.
The found मध्ये पण सेम तसं.
Yes. So temp will be this. Okay. Okay. So that will be there. Good one. Okay. Okay. So anything else? Any other thing you want to say?
हमने वो पोस्ट क्यों दिया हुआ है सर, POS is equal to 1?
जो इस यहाँ का कॉपी किया है ना वो इसे है. Otherwise, you can put the number is at this position, so that we have deleted the element which is found at third position. That also you can mention also. Okay, so is it clear? Searching is clear. Delete is clear.
Yes, sir. Yes.
Okay.
Yes, sir.
So now we'll see the insertion at the element at some certain position. So there will be three possible types of insertion. Okay. So one insertion type that is at head. Okay, that is one insertion. Second insertion that is at tail. Okay, and third insertion that is at position. Okay, so at any in between position, so it may be a need to be placed. Okay, so that we have to work on head, tail, and position. Okay, so just we'll see the things. Okay, so now just tell me. So we'll first write the code head position. Okay, so how to insert at head? Just tell me. Okay, what you'll do is just write all three, head, tail, and position. I will give you 5 minutes. Okay, you just write how to insert at head, how to insert at tail, and how to insert at position. Okay, so just write your routine on that. Okay, so once you have written, you just share into chat. Okay, so on the basis of that, we'll discuss. Okay, so it's now 10:44. So till 10:50, you'll just go through it. Okay, and if you have any doubt in between, you can ask. So there is insertion at head, insertion at tail, and insertion at in between that you can process.
Sir,
Yes.
sir, forward and back button might be application of link doubly.
Forward and backward.
So back button for like a multiplayer or audio player or for a website.
Yes, yes. So, okay, just elaborate more how it will work for that. कसं होईल म्हणजे for any example as we can. Yes. बरोबर आहे तुझं. Your approach is correct. Okay, just can you elaborate that more? 64.
Yes, sir. Sir, elaborate म्हणजे exactly.
म्हणजे थोडं एक्सप्लेन कर रे अजून. म्हणजे एखादं एक्झाम्पल असं बाबा आपण फॉरवर्ड 2 times फॉरवर्ड की इज प्रेस. ओके, देन वी हॅव टू मूव टू बॅकवर्ड असं म्हणतोस का तू?
हाँ सर म्हणजे
हाँ सर अंडू और रीडू फंक्शन भी वैसे ही फिर जैसे हमने कुछ टाइप किया फिर अंडू कर लिया तो वापस पिछले वाले पे जाएगा, रीडू किया तो वापस आगे आ जाएगा.
Yes. Okay. Correct one. Okay. So that is again same thing. Okay. Anything else? Okay. So these are the two correct means because what I already told you in initial lecture of this data structure. Okay. So data structure is not a programming language. It is an approach to program. Okay. So without data structure, you can code, no issue. Okay. If you do some course and join some company, no issue. Without data structure, you can work. Okay. But data structure will help you to improve your what we'll say logic building. Okay, how exactly it works? Actually, what are the inbuilt functionalities that we are using in any advanced language? That backend is in a data structure. Okay, so what exactly data structure is? How to store, how to efficiently access. Okay, and how to work with the data. Okay, so it may be any type of data. It may be a data which we are working on here, integer values or very simple values, but it may be Excel data. It may be a data which is an SQL database. Okay, so it may be any type of data, but the working on that data will be dependent on the backend functionality. Okay, so suppose now we'll take the same example like forward, back, or redo or undo. Okay, so that's suppose. So now same example, if I have to work with to implement with array, so how we can implement that? I need one array for undo and one array for redo. Okay, otherwise we'll have those elements in the same array actually. Okay, so we can make there only, but it's very difficult to manage. Okay, so suppose if anything I want to delete from that, okay, so it's not we are not possible to delete. Otherwise, suppose if you see one example like Google Doc. Okay, so if you remember, Google Doc will give us all the what we'll say in between records also, and you can also manipulate with in between records. You can delete in between record. There will be Google Docs वापरत असेल. Otherwise, you can consider any scenario. Okay, so suppose there are you are now working in a group project. Okay, so there is a common platform. Okay, so where you are coding. Okay, you are updating the code. So Git, if you are aware about GitHub like that. Okay, so there are commonly we are updating on that. Okay, so suppose if any change I had done in between. Okay, and after that, after 1 month, I have to come to that change again. Okay, so I can revoke. Okay, I can just come to the back. Okay, with the help of what we'll say the checkpoints that we have. System also our operating system will also have a checkpoints. We can revert our system to the specific checkpoints. Okay, so there it will help us a lot. Okay, so this we can you just think. Okay, so what are the data structure we are working on? Okay, so these are very simple data structures. Okay, again if you go for the stack and queue, these are very simple data structure. With the same code we have to go with the stack and queue. Okay, singly linked list will implement or array will implement. Okay, so the concept is going to change. Okay, so suppose I have to work on stack. So stack, how the stack is going to operate? So it will have top element. Okay, so any insertion only will be possible from top. There will be no in between insertion. There is no head insertion. Okay, so there will be insertion only from the top. जसं आपण पुस्तक ठेवतो एकमेकावरती. Okay, so if you are keeping books in one above to everyone. Okay, so I can only put the book into the top. Okay, I cannot insert the book in between. Okay, so likewise, if it is a stack implementation, what I have to do? Only one top pointer will be there. Like now we have head and tail pointer. There will be only one top pointer. So from there only we'll insert the thing. Okay, so like on. Okay, so we can work on this. So I hope this is clear to you. So anyone have finished all three?
Yes, sir.
Okay, so will you please share your screen if possible? Otherwise, you will put into chat. Okay.
Yes, sir. I'll share the screen.
Yes.
Yes, sir. So to insert the element at the tail position, we have to enter 1. So then insert the element at head position, so 2. And then at random position, 3. Display. Yes, sir.
Okay, so will you show the code routine, that particular code routine?
Yes, sir.
Any possible, just increase the font if possible. Okay, so now it's visible. Okay, so insert at the tail you did, suppose it is insert at head. Okay, so this is first node star and new node, and next is equal to head. New node next will be head. Head is not null, then head previous is equal to null, and head is null. Okay, so a new node. Okay, so that is good.
Yes.
Okay, so insert at tail, so we have to check at the tail. Okay, so if head is null, it's correct. Okay, so if head is null, then we have to insert at the
Insert
head.
at
Okay.
head. Yes.
So if it's not head, so then node star temp is equal to head. Okay. Then temp next. Okay. So now I think, is there any need to go with the temp to the last position? As we have already tail pointer with us, na?
Sorry?
As already we have tail pointer with us, is there any necessity to traverse with the help of tail temp, because I have to insert at the tail, na? I
Yes,
can
sir.
directly insert at the tail without having the temp pointer.
Sir, but how will we traverse through the end of the linked list? Like, how
Okay,
will we go to the last element now? It's like,
No, we know that tail is the last pointer that is already there, na? I think you are not created in your program.
okay.
Okay,
Okay,
then
just like
we'll
head,
keep two
we
pointers.
can assign temp equal to tail and then temp
Tail,
is
yes,
equal to
yes.
n.
Temp
Okay.
next equal to new element. Okay, and new
Okay.
element previous is equal to temp. Okay, so that will be sufficient. Okay.
Okay. Yes, sir.
So that inserting at the tail and inserting in the position that already we did previously also, it is temp next. Okay, so the position will take from the user, and once we reach to that position, so that new element will be there. So it next will be temp next, and its previous will be temp previous. Okay.
Yes. Yes, sir.
Okay, so no issue. So that's correct. Okay, so I will share
Yes,
my
sir.
screen.
So delete and delete node is also implemented.
Yes. Delete is also there. Okay, so
Yes, sir.
temp not null position will go get. Okay, and that will be deleted. Yes. Okay, good one, Mugdha. Okay.
Okay.
So okay, I will share my screen. Okay. Okay, so it's visible. Screen is visible. Okay. Okay. So I hope everyone gone through this head point of view and tail point of view. Okay. So is there any need to explain it again for anyone? Is there who haven't understood how to work on that? Okay. Suppose I have to insert node over here. Okay. So that is my head position. Okay. So this is new node I have created. So how to insert over here? Okay. This I will make it new node. Okay. So this is my new node. So what I will do, new next is equal to head. Okay. And this head previous is equal to new. Okay. So that is my first pointer switching will be done. And finally I will make head is equal to new. So head will be now this pointer. Okay. So head will be now this first pointer. So which is there. So how to insert that? So now this will not be an head. Okay. So head we have shifted. Okay. So only we have to make new next is equal to head and head previous is equal to new node. So that will insert at the head position. So similarly at the tail, so this is new node I have to place. Okay. So tail next is equal to new node. So tail next is equal to new node, and new previous is equal to tail. Okay, and tail is equal to new. So this tail is equal to new. So tail will not be here. Okay. So tail will be shifted at this position. Getting? Hello.
Yes, sir. Yes, sir.
Yes, sir.
Yes. And in between, we already seen how we have deleted. Same thing we will insert. Okay, so suppose I have to insert one node over here. Okay, so like this I have to insert. Okay, and I will have suppose temp is over. This is my new node. Okay, so that I have to insert. Okay, so my temp is over here. Okay, so what I will do now, it's very simple. Okay, new next is equal to temp next. Okay, so new next is equal to temp next. Okay, so we'll just configure first new previous is equal to temp. Okay, so new previous will be temp. Okay, so now this will be like this. Okay, now which pointers will be remained? Okay, so temp next previous is equal to new. Okay, so temp next previous is equal to new, and we'll just see temp previous next. Okay, so this temp is over here, or this temp next also we can do. Temp next is equal to new. So likewise we'll add the node in between. Getting? Hello.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
So yes. So this is about the things that we have with the doubly linked list. Okay, so finally we'll just go with the single circular linked list. Okay, I hope it's clear, and already we have touched all the points of doubly linked list. Okay, so now we'll have a singly linked list. So sorry, circular linked list. So what is circular linked list? So this is my node. Okay, so this is my first node. This is my second node. Okay, this is my third node. Okay, so this is my third node like this. Okay, so this is my fourth node. Okay, here this is my fourth node. This is my fifth node like this. Okay, so these nodes I have, and we'll just see circular singly linked list. Okay, so it's a circular, not doubly linked list, it's a circular singly list. So we'll have a next pointer over here. Okay, so again this will have a next pointer over here, and this will have a next pointer over here. Okay, so now in normal singular linked list we have what this tell last element next will be null. Okay, so how we can modify this particular linked list? Okay, so the last element will be pointing to the first element, so that way we are working. Okay, so this is called as a circular singly linked list. Okay, so this particular concept, how it is worked. Okay, so this is called as a circular singly linked list. Getting? Hello, getting? Got the basic concept how it is working? So the last element will be attached to the first element. Okay, I'll just show you the diagram actually. So this is the scenario actually. I just not got time to insert that in PPT. Okay, so this is the circular linked list. Last element is connected to the first element. Okay, clear?
Yes, sir.
Okay, so now what are the different possible application? What we'll say operation that we need to perform on the circular linked list, and which are the different pointers that we need to keep. Okay, so as we have in doubly linked list, we have head and tail pointer. So in circular linked list, which will be head and which will be tail?
So there will be no such pointers.
Okay, so but again this circular singly linked list we have. Okay, so now we can keep anyone as head actually. Okay, but any single pointer we can have to keep in reference. Okay, so with the reference of that pointer it's possible to add and delete nodes. Okay, so without which we won't able to enter into the linked list. Okay, कारण एंटरच करता येणार ना आपल्याला एक कोणता तर पॉइंटर ठेवायला लागेल लाईक इन सिंगली लिंक लिस्ट वी कीप हेड ॲज द पॉइंटर, but here we can we keep head or can we keep tail or can we have to keep both head and tail? Okay, so any thought on that? There should be one entry pointer actually, or we need two. Yes.
So we will keep head pointer.
Okay, so there is one thought that will keep head pointer. Okay, so that we have. Okay, so in circular linked list, okay, so there will be one pointer. Okay, so that will be we'll keep head. Okay, other any thought? Okay, wait a minute. Okay, so on this we are discussing. Okay, so what will be the correct? We can say which pointer we'll need? Okay, so suppose now we'll just see the scenario for the insertion of the element. Okay, so suppose we need to insert at the element. So okay, so there will be two possibilities. Okay, so in circular linked list we can keep one head. Okay, so there will be any over here. Okay, so that we can keep. Okay, so like this. Okay, so anything will be there, but there will be always one pointer we'll have. So there are two ways. Okay, so suppose I will consider this list. Okay, so there will be one possibility, because it's not what we'll say, it's a circular, but it's not what we'll say in ordered list. Okay, so suppose I have inserted some number like 2, then 3, then 4, okay, and then 5 and 6. Okay, so now what will be the first element inserted? What is the first element inserted over here?
4.
Yes, am I audible, na? Okay, so what will be the first element inserted over here in this list?
4.
Which is the initial element inserted? Hello? Are you getting what's my question? Which is the first element? I have just explained 2, 3, 4, 5, 6 are the elements. So now which is the first element inserted in this list as per the sequence?
Four, sir.
Sir, it will be 4.
Okay, so 2 is first inserted, yes or no? The element which is inserted, that is 2, yes or no? First element inserted. Hello?
Yes, sir.
Yes. Okay, then okay, so 2 is the first element inserted, so in this list. Okay, so that we have. So now as per the terminology, Okay, so there should be one element which is pointing to this element. Okay, so this is position. So I will say POS. So that is my position we have. Okay, so POS we have over here. Okay, so what is the benefit of having element over here at this position? Okay, so with the reference of this position, if any requirement in the circular list, okay, so to insert the element before head, so directly we can insert, because if we keep head element only, and there is a requirement that insert the element at the last of the circular list, because we know that how the elements are inserted. Okay, so that should be in sequence. Okay, it will only grow with the sequence. Okay, so still it's a circular, there is only the main necessity of the circular linked list. Okay, so the last element should be pointing to the first element, so that is the main necessity. But in between, okay, so there should be a start element. But now if we keep this position element at the last, okay, so with reference to this position element, we can directly place one element before head. Okay, so that will be over here. Okay, so that will be like this. And anyone have told, okay, so the insert the element after tail. Okay, so both will be the same thing. Okay, and if any requirement is that insert after head, so that we can insert over here only. Okay, so but with the reference of head, if any requirement is that, so insert element after tail, so I have to create one temp element over here. Okay, same thing, we have to traverse from all the elements in the list. Okay, and we have to reach to the last node. Okay, and we'll insert over here. So there will be a pointer will keep at this position. Getting?
Yes, sir.
Yes, sir.
Hello? Okay, so I think it's clear. Am I audible? Na? Hello?
Yes, sir.
Yes, anyone?
Yes, sir.
लेक्चर बोर झालेत का तुम्हाला? काय रिप्लाय नाही, काय नाही? हॅलो
सर तुम्हाला ऐकू येत नाहीये? मे बी वी आर रिप्लाइंग.
Okay, sorry. I think it's muted. Okay, no issue. Okay, I hope it's clear to you. Okay, I think I just muted. Okay, in between. Okay, then this is about the doubly linked list and singly linked list. Okay, next lecture we'll just finish up the implementation of singly linked list point of view. Okay, so that implementation will finish, and there will be a last point of this unit. Okay, probably we'll cover up in next lecture. Okay, so that will be polynomial what we can say operations. Okay, so that we already covered, means just have a thought, okay, how the polynomial will be worked on that. Okay, so this is about the linked list working and operations. Okay, so I hope it's clear to you. And regarding to your assignment of doubly linked list, in next tomorrow's session, we'll just we'll just discuss that in short detail. Okay, and there will be submission of this linked list, doubly linked list assignment will be on your HackerRank platform. Okay, so
Yes.
that code and how it will be conducted, it may be a HackerRank or it may be a CodeShape, any other platform it may be. Okay, but there will be submission only on that platform, because that is recommended in our syllabus for doubly linked list assignment. Okay,
सर हे पहिलं असाइनमेंट असेल ना डबलचं?
हा डबली लिंक लिस्ट एकच असाइनमेंट आहे, पहिलीच आहे ती. त्यामुळे आपले आता 2 असाइनमेंट 3 असाइनमेंट झाल्या. फर्स्ट आपण हॅशिंगची घेतली, दुसरी सिंगली लिंक लिस्ट आहे आणि तिसरी डबली लिंक लिस्ट आहे. तर 3 असाइनमेंट तुम्हाला राईटअप्स मिळतील आणि सबमिशनचा मोड कळेल. पण जे सबमिशन राहील डबलीचं ते हॅकर रँकवर राहील. हॅकर रँक किंवा कोणता तरी कोडिंग प्लॅटफॉर्म राहील. ठीक आहे, एनी डाऊट?
No, sir.
ठीक आहे, देन थँक्यू, हॅव अ नाईस डे, बाय.
Thank you, sir.